Good afternoon to all my viewers. In this video, I like to discuss about practice paper part 1 as well as part 2. This video is the extension of the previous video. We'll start from job number 21. A massless platform is kept on a light elastic spring as shown in the figure. When particle of mass 0.1 kg is dropped on the pan from a height 0.24 meter, the particle strikes the pan and the spring is compressed by 0.01 meter. From what height should the particle be dropped to cause a compression of 0.04 meter? Here conditions are taken: the spring is massless, not going to absorb any energy, and the during collision there is no loss of energy. Now as when mass will fall on the pan, it will compress say x distance, that is given here 0.01 meter. Let us say x. Algebraically we have to get the equation. Now loss of potential energy, we can take this type of equation: mg h plus x, mg h plus x, that will store as a potential energy in the spring, that is half k x square. X is given in this problem 0.01. After substitution, m is also given 0.1 kg, 10 is small g. After substituting all, we can get value of k. It is half into 10 to the power 4 Newton per meter. Now question is that from what height it should be released on the pan so that it will compress 0.04 meter of the spring. Now by same pattern of equation, mg within bracket h dash plus 0.04 will be the total loss of potential energy of the system, that will stored in the potential energy of the spring, that is half k is known, half to 10 to the power 4, x is here 0.04 meter given into whole square. From this equation we can substitute, we can find out this h dash, that is 3.96 meter. Now come to next job. A particle moves in the xy plane with velocity vx equal to 80 minus 2 and vy equal to 2. If it passes through the point x equal to 14 and y equal to 4 at time t equal to 2 seconds, then the equation of the path has to be in terms of x and y. 4 choices are given. Let us see how we can do this job. Now dx by dt is given here, that is how much, 80 minus 2, it is given. Now v means dx by dt, that is given. Just arrange for integration. 0 to 14 will be the limit, where it will pass through 14, so 0 to 14 will be the limit for at a time 2 seconds, that means 0 to 2 will be the limit. Now after integration we will see that this will come in this form, that is x 0 to 14 here 4t square minus twice t plus c will come. Substitute the limit and we can get c will be 2. And if we put 2 here, x equal to, in this equation, if we put value of c here, in the here 2, then expression will be this one, that is x equal to 4t square minus twice t plus 2. Now another equation is available from v suffix y, dy by dt. This one is given to, so y will be coming twice t. Now here t will be y by 2, y by 2. Substitute this one here, and it will give this type of equation, x equal to y square minus y plus 2, and answer will be A. Now answer will be B here, x equal to y square minus y plus 2. This will be the answer. Now come to next job. Two bodies of masses 10 kg and 2 kg are moving with velocities. Velocity for 10 kg mass given as well as 2 kg mass given respectively. The velocity of the center of mass is, for center of mass we know that the equation of center of gravity is known, that is xm equal to, we can write x1 m1 x1 plus m2 x2 divided by m1 plus m2. Then differentiate, you will get xcm. xcm will be m1 v1 plus m2 v2 divided by m1 plus m2. Now m1 given, m2 given, v1 v2 both given, just substitute here and find out, and it will give us 24 by 12, I mean 2k will come. That center of velocity of the center of mass will be twice k meter per second. Now next job. A satellite is launched into a circular orbit of radius r around the Earth, while a second satellite is launched into an orbit of radius 1.02 r. The percentage difference in the time period is. This is a good question. How to do? We know from Kepler's law, directly you can use t square proportional to r cube, or you can derive some other way also. Now t square equal to, we can write k r to the power 3. Differentiate this, you will get twice t dt equal to k. It will give you 3 r square dr, and bring this 2 will come from here. This one mistake. From here we can again divide this expression by this one, t square equal to k r cube. Divide this, you will get twice k dt by t. dt by t, there you can see this will cancel, 1 t will cancel, and bring this 2 in this denominator, 3 by 2 will be here, and in the right side it will be r square will cancel here, 1 by r will be there into dr, that is 3 by 2 dr by r will be there. This expression is important, you just keep this one in your mind so that it will give you advantage. Now from here we have to find out data is given, dr is given, difference of the radius, that is 0.02 r, divided by the actual radius, that is r. Here r is not radius of the earth, or even let us see in the question. Here capital R is the radius of the circular orbit from center of the earth, that is capital R. It is not that radius of the earth. Now whatever it is, our interest to find out percentage dt by t into 100 will be the percentage, that will be the that will give us 3 by 2 into dr by, dr is already known, that is here 0.02 r divided by r, we will cancel this into this 0.06 divided by 2 into 100 will give 3%. 3% change will be there in the time period. You can see answer is D. Two men weighs in the ratio 4:3 runs up a staircase in time in the ratio 12:11. 12:11. The ratio of power of the first to the second is, we can do in this way. Power for the first man is W1 H1 by T. W1 means weight, M1G, that is W1, M1G into H1, that is potential energy gain divided by time. Similarly, for the power expression for the second equation, W2 H2 divided by time 2, T2. Take ratio P1 P2, it will give W1 by W2, H1 by H2 and T2 by T1. Here will be reciprocal. You just check this properly. Now substitute this 4 by 3 is given here, 4 by 3, and height is same height, H1:1. Then time is given in the problem, that is 12 by 11. Now you have to put 11 by 12 because it is in reciprocal form. So now put in this form 11 by 12, simplify, P1 by P2 will come 11 by 9. D will be the answer for this question. This one, 11 by 9 is the answer. Next job. An object is kept on a smooth inclined plane of height 1 unit and length L units. The horizontal acceleration to be imparted to the inclined plane so that the object is stationary relative to the inclined plane. And we know that horizontal acceleration required is g tan theta. That is, the basic is known to you. The basic is known to you. That is g tan theta. Then only it will be easier job. Now, otherwise you have to derive that the basic equation. That is A, which is required to give on this inclined block, inclined wedge in this direction towards left side, so that the mass will what it will be on this inclined plane, it will remain raised. That is g tan theta. You can derive very simply. Suppose the pseudo force will experience on this mass. If a mass is placed here, that will be this direction, and say acceleration of the wedge is towards left side A cos theta will be upward and g sin theta is downward. This should balance. Then A will be g tan theta. That is available. Now put tan theta from this triangle, perpendicular by base. L is given, perpendicular is 1, so root under L square minus 1 will be the base. Put it here, perpendicular base, g by root under L square minus 1 will be the acceleration required to give. Now come to next job, that is dimensional formula. Now you can see force equal to given by AT plus BT square by AB are two positive constants. The dimensions of A and B required to find out. Very simple. Force is ml t to the power minus 2, and here it is right side AT. Remove 1t, then A will come. That means it will be see from here. ml t to the power minus 2 is force divided by 1 time, capital T. The t to the minus 3 will be there. ml t to the power minus 3 for small a. Similarly for small b, it will t to the minus 4, ml t to the power minus 4. I think A is the choice here. Next job. The speed of a projectile when it is at its greatest height is root under 5 by 2 times its speed at half the maximum height. What is the angle of projection? The speed of a projectile when it is at its greatest height is root under 5 by 2 times its speed at half the maximum height. I mean, when it is at its capital H by 2 position, whatever velocity it has, that will be, you can see, solve this in this way. This is the projectile path shown here. Say here it is theta in the angle, u cos theta will be the horizontal. When reach at its maximum position means only u cos theta will be there. Now in the question it is given that u cos theta, suppose after maximum height is h here and here it is h by 2, and at that time velocity is v. V cos alpha will be u cos theta. U cos theta always in the horizontal direction, that remains same. So V cos alpha will be this one. What V sin alpha will be in the other side. I mean u sin alpha in the u sin alpha is the initial velocity at the starting point velocity in the vertical direction. And at this position, say it is v suffix y whole square will be initial velocity u sin theta in the upward direction minus twice g, height is given h by 2. 2 get cancels, your expression will be this one. Then what to do? You know, along this direction velocity is known, Vx is known, that is u cos theta. That means this one square plus vertical one square, Vy square plus Vx square, sum of these two will be the resultant. Now you know that Vx is always u cos theta, you substitute this. This will be u square cos square theta, cos square. U square cos square theta plus instead of Vy already you got it, that is this one, u square sin square theta minus gh. Now take out u square common here, you will get u square minus gh, that is V resultant. According to question, that is to be noted here that resultant velocity at this position, is how much? Now it is root under 2 by 5 into this velocity v suffix r will be the velocity at its highest position. This is the most important part of the question, that is this one, this equation. The condition which is given, root 2 by 5, root under 2 by 5, whatever velocity at h by 2 here, that is equal to highest point velocity. Highest point velocity is only u cos theta. Now already you know Vr is this one. I mean you can substitute in this form, that is root under 2 by 5 and this is root under u square minus gh equal to u cos theta. Then square both the sides. Squaring you can organize, you can substitute h also. You know h will be how much? Maximum height, u initial velocity u sin theta, that will be u square sin square theta divided by twice g, that is maximum height equation. So for height h you can replace u square sin square theta by twice g. Little bit simplification is required here. U square take out 1 this will come to g here. You will then simplify, just LCM simplify here. You will get this equation. This one will be available. Now from here you can see 4 cos square theta equal to 1 will come. This is not a tough job. You just simplify this one, 5 into this one, and You have to simplify here, and you will get 4 cos square theta will be 1, that is cos theta will be half, and we know that theta will be 60 degree. That means angle of projection of the projectile will be 60 degree. Important point. Now this job is over. Now come to job. A ball of mass m is thrown vertically upwards. Another ball of mass twice big m is thrown at an angle theta with the vertical, not with the horizontal, with the vertical. Both of them stay in air for the same period of time. The heights attained by the two are in the ratio. We have to see ratio between the height of mass m and mass twice m. That is required to find out. Simple job. This is not a complex one. Now we know that for projectile maximum time of flight is twice u cos. This is minded. This is theta here. In this question, this angle is theta. So u cos theta will be the perpendicular velocity, vertical velocity, and u sin theta will be the horizontal. Actually, we require to find out time of flight. That will be u cos theta, twice u cos theta over g is the time of flight. Now height will be u square. When I mean initial velocity upward direction, that is u cos theta square by divided by g twice g. When I mean u square cos square theta by twice g will be height. Now for the mass small m, which is not in projectile, simply thrown upwards, small h will be half g t square. I mean here time will be for horizontal position, ground position to highest position, it will be definitely half of the time period of the projectile path, because both will stay same time in air. That means t by 2 will come here. That is the advantage here. Small h we can write half small g capital T time of the projectile by 2 whole square. Now take the ratio between these two heights, this one and this one. You will get this type of expression, that is g square by 8 capital T square u square, all these things will come. Now put this t is known here, substitute this one here, and at the end h small h by big H will come 1:1. This is a simple job. First you have to take care of this thing, that u cos theta will be the vertical velocity. Once you can do this, time of height, maximum height equation is available. Then the mass which is only fired upward, that is h, it will be half g, half of the time of flight, that is d by 2 whole square, and just we have to take the ratio of the heights, we can get it. Next job will be on a 2-lane road, car A is traveling with a speed 36 km per hour. Two cars B and C approach car A in opposite directions, with a speed 54 km per hour each. At a certain instant, when the distance AB equals to AC, both being 1 kilometer, 1000 meters, B decides to overtake A before C does. What minimum acceleration of car B is required to avoid any accident? I mean 36 means 5 by 18, 5 by 10 meter per second, and 54 means 15 meter per second in terms of meter per second. Let us see how we can solve this job. This is car position A. B is coming, say 2-lane road is there. Suppose A is here, B is here. B is approaching towards A and C is also approaching towards A. These two are opposite in direction. but when their distance between AB equal to AC, I mean 1 kilometer, 1000 meters, this gap is 1000 meter, here also 1000 meter. B wants to overtake A. That means it has given an acceleration. So what to do? Say A after time t, this B can overtake. This will travel x distance, and B has to travel 1000 meter plus x distance, and this will travel 1000 minus x distance. C has to travel only 1000 minus x distance. Okay, this would be the, now taking that B has given acceleration x plus 1000 meter will be initial velocity 15 meter per second into time plus half a t square. This is a simple one. Now come to equation for C car, that is 1000 minus x equal to 15, it will move with constant speed, 15 into t. This is another equation. From here, these two equations we can get twice x equal to half a t square. Now for car A, it is going with uniform speed, that is 10 meter per second, that is 10 into t, 10 meter per second. This one, x will be, it will go x distance, is it not? A is going x distance, so x equal to 10 into t. Substitute, use these three equations, and you will get, you just utilize these three equations, simplify, you will get 25t equal to 1000 will come. 25t equal to 1000. T will be 40 seconds. I mean after 40 seconds, B can catch the car A. Then we have to find out acceleration. Now time is known, and we need to get acceleration. So acceleration is available, that is 40 by 40 will come 1 meter per second square. You can substitute here also. T 10 equal to 1 by 4 a t square is there, t cancels, and t already we got 40, that means a will be coming, a will come 1 meter per second square. That is the required acceleration to catch the car A. Now this job A31, if the vectors A and B parallel to each other, the magnitude of B is given 5 I minus P j cap, 5 I cap minus P j cap. We know that A cross B equal to 0, that means A and B parallel, simple idea. Now use this one, this pattern. A cross B will be A B mod A mod B sin parallel means 0 degree, so this part will be 0. I mean take determinant form, that I j k cap, and use, you know that A is given, in the question, you can see that is 2 and 4 is the coefficient of I and j. Now accordingly it is being put here 2 4 0, then 5 minus P 0. Then simplify this and you will get 20 plus twice P equal to 0. P will be minus 10. I mean P will be plus 10 because minus P here. I mean instead of minus P you can say 10. So B will be 5 I minus 10 J. I think B, actually in the question it is asked magnitude of, you can see here, magnitude of B. Then we know magnitude of B means root under coefficient of I, that is 5 whole square, minus 10 has come, that is root under 5 square plus within bracket minus 10 whole square. This will give you 125, that is 5 root 5, that is the magnitude of. Now next job, That is, the force on a particle of mass 10 gram, that is given here. If it starts from rest, what would be its position at time t equal to 5 seconds? Force is given. That means you know that force is mass into acceleration. Use this equation. Force equal to mass into dv by dt. From here mass is given, so we can get this equation. dv by dt will be, mass is 10 gram divided by 1000 will give kg, so it will give 100 into this one. And just for the integration, simplify in this form, rearrange and integrate this, you will get dv equal to this type of equation. And if we are interested about distance travel, then again break it. Once v is available, ds by dt, then again integrate. After integration, you will get final expression will be 100 within bracket 125 I cap plus 2.5 into 25 into j cap. That means multiplied by 100, you will get the actual expression. I think here it is A is the correct one. It is a very simple job, so you can do yourself. Now a mass of big M 100 kg is suspended with the use of string A, B and C as shown in the figure. W is the vertical wall. W is the vertical wall and R is a rigid horizontal rod. This is R, this is vertical wall. Okay. And the tension in the string B. We have to find out tension in the string B. This is also a very simple job. You can do in this way. You break the tension, this slant tension which is shown here. This angle is given 45, so T cos 45 will be in this direction and T sin 45 will be in the upward direction. T sin 45 will take care this mg load, weight of this mass, and T cos 45 will be equal to TB. T cos 45 will be, now you can take B is T C which is here cos 45. Now TC 45 means 100G is coming. TC is available. Thereafter put it here. TB is required. So 100 root 2 again 1 by root 2 cancels, 100G Newton. That will be the answer for this. A is the answer. Job number 32. Up to 31 we have completed in earlier video. 32 onwards we will proceed. An electric current of 5 ampere is passing through circuit containing 3 wires arranged in parallel. If the lengths and radii of the wires are in the ratio 2:3:4 and 3:4:5, then the ratio of current passing through wires would be. You can do in this way, say 3 resistance are parallel, V is the supply, then I1 same potential for all, I1 will be V by R1, I2 will be V by R2 and so on. Now resistance means rho L by A, that is also known to you. Now we are interested about I1 is to I2 is to I3, that means it will come V same for all, so remove 1 by R1 plus is to 1 by R2 is to 1 by R3. Now what is R1? R1 means rho L1 by A1, the A1 will come in the numerator. Same thing here, A1 by L1, A2 by L2, A3 by L3. This will help you if you know up to this equation. Say what is area? Area will be here cross section of the wire is round, so pi r square will be the area. So pi r1 square, pi r2 square and pi r3 square, in this proportion pi is common, so it can remove. So final expression is r1 square by L1 R2 square by L2 and R3 square by L3. This is the least form of current ratios. I mean I1 is to I2 is to I3. We can jump to this expression. R1 square by L1 is to R2 square by L2. You keep this one in your mind. That will help you. So many things you need not to do. You just take this one and just put data and get the answer and mark it immediately. Now R1, R2, R3 is given. This is given. Now squaring, you put it in the numerator. 3 square, 4 square, 5 square, then divided by 2, 3, 4, 2, 3, 4, and then automatically you will get the simplified form. Take LCM, multiply it, and 54 is to 64 is to 75. That will be the answer. D will be the answer. Where it is? This one. Now come to next job. The masses of neutron, proton, and deuteron in AMU are given. Respectively, the packing fraction of the deuteron in AMU is packing fraction, that is mass defect divided by the fundamental formula for packing fraction is mass defect divided by mass number. Mass defect divided by mass number. Now here Z is the for proton, Z is the atomic number, and this is the atomic mass minus Z into neutron number. Mass of neutron is mass of proton, and minus mass of nucleus of deuteron divided by atomic mass, atomic number of mass number of deuteron. Now you know that. We can put all data are available. You can see this is given here. For neutron it is given, for proton it is given 1.00813 is for proton, this is for neutron. A minus Z will give neutron, mass of neutron, then multiply 1 into this one plus 2 minus 1, that means 1 into this one minus nucleus of, that is also given 2.01473. Put it divided by 2. Divided by 2 will give this. A is 2. Now put 2 here, you will get this one 0.001165. This one in terms of AMU. If you this is in terms of AMU, atomic mass unit, that is 11.65 10 to the power minus 4 AMU. Simple job. Only thing you have to know the formula. 11.65 into 10 to the power minus 4 will be the answer. Now come to next job. Shunt required to an ammeter of resistance R to decrease its deflection from 30 ampere to 10 ampere. I mean deflection depends on Ig. As we want deflection for only 10 ampere, then Ig proportionally decreases. That means initially Ig was 30 ampere, now deflection 30 ampere, maximum deflection to 10 ampere we require. That means we have reduced 20 amps. I mean 2/3 Ig and the new resistance through which resistance current will pass. If current was coming here Ig, now if you want to decrease this range, then divert the current in this direction, that is R dash is the resistance. So this current will be 2/3 Ig into this resistance, which is equal to Ig/3 into R. Very simple logic. Potential drop will be same because they are parallel, so R dash will come R/2. You have to know the idea only. Now come to next job. In a Young's double slit experiment, D equal to 0.5 mm and capital D 100 mm, it is found that nth bright fringe is at a distance of 7.5 millimeter from the second dark fringe of fringe pattern. The wavelength of light used here. Now it is distance given 7.5 mm, that is second dark to ninth bright fringe. Let us see. We know path difference delta is d sin theta. That is equal to, if it odd multiple, I mean 2n minus 1 into lambda by 2 means it is for dark. If it is bright, then 2n into lambda by 2. We can take that expression. Now path difference for, we know that d sin theta can be written d tan theta, which is equal to y1 by d. I mean on the screen from central max to the distance is y1 by the distance between the screen and the slate. That small d, this is there, d small d into y1 by capital D. That will give this one. This is, we are talking about second dark, means 2 into 2 minus 1, that will give us 3 by 2. This one. Suppose we are y equal to how, what? Big D by small d, 3 by 2 lambda will come. This is second dark. Now as it is being told that if we are looking for bright, this will be twice n into lambda by 2. Now for ninth bright, I mean twice into 9 into lambda by 2, and this is there as we are looking for y2, that is d by big D by small d is there as earlier, 2 into 9 within into lambda by 2. Now this is 18 actually. So this is ninth bright fringe. Now y2 minus y1 will give the distance between the second dark to ninth bright. That means big D by small d is common. This is 18 minus 3 by 2, 1.5. By 2 is here also. Now this is 18 means 9 minus 1. This we can simplify in this way. Oh, lambda by 2 is taken here. So this will be 18 minus 3 into lambda by 2. Now from here we can get 15 by 2, 7.5 into 10 to the power minus 3, because this is given in terms of millimeter. This is given in terms of millimeter. So we'll get, I mean this distance is given in terms of millimeter. That means 7.5 equal to 10 to the power minus 3 equal to this expression. Now from here we are interested about lambda. That means lambda we can write down in this way. That means this factor is again 7. We will cancel, substitute all the 0.5 by 100. You simplify and you will get lambda will be 5000. You have to take care of these two relations. Only this one minus this one. This value is given. That is 7.5 millimeter. I mean 7.5 into 10 to the power minus 3 equal to this one. D is known 100. This is 0.5 most probably. 0.5 and this difference is 15 by 2 means 7.5. Left side right side 7.5 will cancel. Small d by big D will come. That we have to convert in terms of angstrom. Then only 5000 angstrom will come. Okay, simple job. Next job is at a given place on the Earth's surface, the horizontal component of Earth's magnetic field is 3 into 10 to the power minus 5 Tesla, and resultant magnitude of the field is 6 into 10 to the power minus 5 Tesla. Resultant is given. Resultant cos theta will be the horizontal component because angle of dip is theta. So resultant B cos theta will be equal to 3 into 10 to the power minus 5 Tesla. That is the point. Let us see how we can solve this simple job. BH horizontal will be B cos theta. That is the point. B is given, BH is also known. This value is given. Horizontal component is given. Resultant also given. This resultant value also given. this one known, cos theta will be known. Cos theta is half, so theta will be 60 degree. Okay. Now 37. Which one of the following combinations of radioactive decay results in the formation of an isotope of original nucleus? I mean, nucleus will remain same number of that is number of protons and neutrons will be same. That is possible how? 1 alpha 4 beta will increase 4 atomic number, this combination, this will reduce to increase 4, that is not possible. For the second choice, 1 alpha means atomic number will reduce 2, that means Z minus 2, 2 beta particle increases, matlab it will return to Z again. I mean, it is coming back to original nucleus. 2 beta, 1 alpha, 2 beta. Atomic number not going to, atomic mass is not going to change, so B will be the answer. Let us see C. 1 alpha, 1 beta can compensate one atomic number, Z atomic number will increase, decrease 2 or increase 1, so it cannot return to original nucleus. You have to come back to original nucleus, that is to be noted here. Now 4 alpha, it will reduce 8, Z minus 8 will be there, 1 beta, that is not possible. P is the answer here. Now next job is quantity that remains unchanged in a transformer is voltage can step up, step down, current also accordingly responds. Frequency is not going to change. Frequency is the fundamental, depends on source only, not on the transformer. Thank you very much for good listening. Prepare very carefully. You have to step up your position and hope that you are doing well. Also like the video, so that share. I am very much interested about if you can share it so that other people can get this benefit. So hope that you will, by mistake at least you will share this one. Sometimes you may prefer to like also. Thank you very much. Wish you a good day.